Hey class, this is a one-touch does-it-all video for pH and everything about it. We're going to do 4 different types. First off, pH, then pOH, then solving for hydrogen concentration or the hydronium concentration, then solving for the hydroxide concentration. First off, let's start with pH. pH. The first question says, what is the pH of a solution with a hydrogen ion count of 4.5 times 10 to the negative third power, and is it an acid, a base, or a neutral? First off, you have to identify your formula. And the formula when you're given a concentration and you're trying to find either pH or pOH is to take negative log of your concentration, in this case 4.5 times 10 to the negative third power. Now again, when you do that, you're going to have to hit negative, control, and then the 10x button. You'll come up with the screen that looks like this, negative log. You'll have 2 boxes. You want to skip the first box, hit your arrow over to the right to get into this box, and that's where you'll type in your concentration. So that being said, let's figure out what that comes out to be. All right. Negative log, scroll to the right, 4.5 times 10 to the negative third. That gives us 2.34 679. We're going to round to 1 decimal place. That's going to round to 2.3 for our pH. Now, is 2.3 an acid, a base, or a neutral? Hopefully we know by now it's a very strong acid. Okay, moving on. pOH is the exact same as pH, except this time we're talking about the hydroxide count and the percent hydroxide. So, given one or the other, we can solve for the opposite. What is the pOH of a solution with a hydroxide concentration of 2.1 times 10 to the negative fifth? And again, is it an acid, a base, or a neutral? We're going to use the same formula, negative log of 2.1 times 10 to the negative fifth. And plug that in our calculator. Negative, control, 10x, scroll to the right, 2.1 times 10 to the negative fifth. And that gives us a total of 4.67778. Again, we're going to round to 1 decimal place. That's going to be 4.7. So our pOH is 4.7. Now, can we get whether it's an acid, a base, or a neutral from this? Not directly. pOH plus pH have to equal 14. So keyword pH plus pOH have to equal 14. No questions whatsoever. If our pOH is 4.7, to get our pH, we just subtract it from 14. 14 minus 4.7, and that gives us 9.3. So if our pH is 9.3, then is our substance acid, base, or neutral? The answer would be base. So don't get confused on those and accidentally say, oh, it's a 4.7 for the POH and think it's an acid. You have to go back to pH. That's what our scale is measured on. Next up, you're looking for the hydrogen concentration. Now again, hydrogen and hydronium, same thing. Same formula, same way to solve for it. What is the hydrogen concentration of a solution with a pH of 3.2? The way to solve for these, hydrogen concentration equals 10 to the negative pH power. So on your calculator, you're going to hit the 10x button and then type in your pH. So over here, I'm going to hit 10x negative 3.2. So 10 negative 3.2, and that gives me 0.000631. Now we don't like that. We don't like that number. It's pretty nasty. We're going to put it in scientific notation. Our decimal point is going to have to go right here. To get there, we move 1, 2, 3, 4 spots. So 6.31 rounded to one decimal place is just simply 6.3 times 10. And don't forget, we went to the right, so it's negative fourth. So our hydrogen or hydronium count for this particular problem would be 6.3 times 10 to the negative fourth. Lastly, hydroxide count. Hydroxide, hydronium, same steps. You just need one or the other. You need pH for hydrogen, you need POH for hydroxide. What is the hydroxide concentration of a solution with a POH of 2.1? Same formula. We're going to hit hydroxide this time, concentration, equals 10 to the negative P, and don't forget we're using POH to get hydroxide. So for this problem it's going to be 10 to the negative 2.1 power. So hit your 10x button. Negative 2.1 gives you 0.007943. Again, we don't want to put that as our final answer. We want to put that in scientific notation. So we're going to put that decimal right there. We need to move 3 spots. We need to round to one decimal point. 7.9 is not going to change. So our final answer is going to be 7.9 times 10 to the negative power, negative third, excuse me. This is our hydroxide concentration. This is our hydrogen concentration. Now, with these 4 techniques, you can get from anything. You can get from the hydroxide concentration to the pH. You can get from the POH to the hydrogen concentration, and vice versa, using these 4 techniques. I hope this helps you for the acid-base test. Did I say test? Acid-base quiz coming up next class.